Okay, so let's do in class 9, number 2. It says let S be a right triangle with vertices 0, 0, 1, 0, and 0, 0. Let R be a triangle with vertices at 9, 21, 14, 29, 11, 22. So find an affine transformation, so again it looks like this, such that T of S equals R. So my right triangle I've graphed on here, it's on the UV axis, and my other triangle up here, it's in XY, so I put it here. So I'm looking for a mapping T that takes this guy into that one. So I'm going to want, or need, say T of 0, 0. So I want this guy should map onto that one, say, that'd be 9, 21. And then I'll want T of, say, 1, 0. That's that one right there, to go on to that one, which is the 11, 22. And lastly, I want my T of 0, 1 to go to the remaining one, so 14, 29. Okay, so how I map these isn't that important actually. I could have put 0, 0 to a different point, but it just seems that's the most natural for this one. So let's find conditions on the A's and B's that make this work. So let me erase a few things. Okay, so we have this. So here's our conditions we need over here. So note here, let's look at T of 0, 0. Well, that means 0 for U, 0 for V up here. So putting 0 in place of U here, be gone, place of V here, be gone, just be C1. Comma, then putting 0 in place of U here, gone, 0 in place of V here, gone, to just be C2. We want that to equal our 9, 21 over here. So 9, 21. So this implies then, well, the C1 would have to equal 9 then, so C1 is 9, and C2 would have to equal 21, and C2 is 21. Let's box those. Next, let's look at T of 1, 0. So that's U is 1, V is 0. So again, plugging up here. So at this point, actually, I could now take away my C1 up here and replace it with 9. I can take out my C2 and replace it with 21 now. Okay, so now putting 1 in place of U, you have an A1 there, because it'd be 1 times A1, so it'd be A1. Putting 0 in place of V, that would be gone. I can write a V1 times 0 if you want. So I'm going to take it away. Taking it away here. So it'd be plus 9, comma. So putting 1 here in place of U would be A2. Putting 0 in place of V would be gone, and be plus 21. That has to equal now 11, 22. So it means we have A1 plus 9 has to equal 11. And A2 plus 21 has to equal 22. So subtracting 9 here, let's see that A1 then would have to be 2. And subtracting 21 on both sides, A2 would have to be 1. So we got those two. And what we can do now is just go back up to my A1 here and put a 2 here. And my A2 is a 1, so put a 1 there. So we got that. We're just left with the B's now. So lastly, T of 0, 1, so that's now my U. That's my V. So going up here, putting 0 in place of U, 1 in place of V. So it'd be just B1 plus 9. 0 in place of U, 1 in place of V. So it'd be B2 plus 21 has to equal 14, 29. So you'd have then b1 plus 9 is 14, and b2 plus 21 is 29. So here you have then b1 equals 5, solving that, subtracting 9, and it says b2 would be 8. So up here then our b1 is 5, and our b2 is 8. So this is our transformation here. So we're done with part A. So let's move on to part B now. Okay, so here's part B. Use the change of variables theorem with the affine transformation from part A to find double integral over region xy dA. So the xy is my f. So by change of variables theorem, this will equal then double integral over s of f of t u v times the Jacobian times du times dv, or it could be dv du, doesn't matter. Here, in our case, this is the rectangle from part A, sorry, the triangle from part A, and this is the right triangle. So I have my affine transformation at the top up here. So let's find the Jacobian. So to find the Jacobian, this right here would be your x. This right here would be your y. So let's find the Jacobian. So I've written my definition of Jacobian here. So again, this is my x up here. So it'll be derivative of x with respect to u. So derivative just be 2, because it'd be 2u. Derivative of x now, so this guy with respect to v would be 5. And moving on to the y guy, derivative of y with respect to u would just be 1. Derivative of y with respect to v would be 8. We go this times this, 16, and this times that, minus. So it's 11. Okay, also here, let's look at f of t u v. So our function here is xy, but going up here again, that's my x. So it's going to go in place of the x here, so it's going to be 2u plus 5v plus 9, and times my y, which is 8 plus 8v plus 21. So let's multiply this out. Sorry, I just noticed something. I have my wrong f here. For this question, actually, it should be x plus y. Okay, so let's make it x plus y. That's going to change this then to plus here. So it'll be plus u plus 8v plus 21. Okay, so adding those, we'll have 3u plus 13v plus 30. Okay, so now let's integrate. So let's erase some things here. Okay, so here's what we have. So we found the Jacobian was 11, and so we also found another line here. So it'd be integral over s. We have to figure out what s is in a second. Well, we know s is the right triangle, but we found the integrand here was 3u plus 13v plus 30. I'm going to do dv du. The choice is yours. You can do du first or dv first. Okay, and then the 11 here for my Jacobian, I'm going to pull out in front of the integral. This. So let's figure out what the limits are going to be on this. It's not going to be 0 to 1, 0 to 1, because let's just recall here our region S is the right triangle. So like this. Okay, so I'm integrating with respect to v first, so use a constant in that, so pretty much you're doing strips this way. This is my v, my u down here. So this point down here we could label as u, comma, 0, and a point up here we could label as u, v. So we have to find the equation of this line here, because I need to write v as a function of u. Okay, so let's see here. So the slope, so this down here would be 1, 1, 0. This guy up here would be 0, 1. So the slope then, so it'd be rise, so let's look at this one, so it'd be 0, minus 1, overrun, so it'd be 1, minus 0. So it's going to be minus 1 or slope. Okay, so then using the equation of a line, then it'll be, so in place of thinking of v like a y and the u as an x, so it's going to be v, let's take, say, this point here, so v minus v1, so v minus 0 equals slope minus 1, then u minus 1. So then this equation would be, multiplying the minus 1 in, will be minus u plus 1. Okay, so now we can do the limits on our integral. So let's do it here. So it's going to be, let's just adjust this one here. So this strip goes from 0 to v, but v is negative u plus 1. It's going to go from 0 to minus u plus 1. And the u is going to go from 0 to 1. So it'd be 0 to 1. So that would be your integral. Okay, so let me just erase this picture now. Okay, so let's start to integrate. So we're integrating with respect to v first. So it'd be 11 in front, then 0 to 1, and then integrating this guy with respect to v, it'll be 3 u v plus 13 v squared over 2 plus 30 v, and this will be evaluated at 0 and minus u plus 1, then we'll do du after that. So I'm going to put negative u plus 1 in place of v everywhere. So then we'll equal 11 in front, integral 0 to 1. So putting negative u plus 1 in place of v, it'll be 3 u times negative u plus 1 plus 13 times negative u plus 1 squared over 2 plus 30 times negative u plus 1. That will be du. Okay, so to simplify things a bit here, I'm going to say let w equal negative u plus 1, then du would be minus 1, so then dw equals minus du, so then du equals minus dw. So let's make the substitution now. This then will be equal 11 in front, 0 to 1. Well, I got to substitute for u here, so actually I got to solve this for u. Set up here. So it's subtract 1, so you'd have negative u equals w minus 1. And multiply both sides by a minus, so you'd have u equals 1 minus w. So it's going to be then 3. In place of u now we can write 1 minus w. Then w plus 13. Oh, sorry, we need to change these limits too. This should be w of 0, w of 1, so w squared over 2 plus 30 times w times du, but du now is negative dw. Okay, so let's see, w of 0, w is here, so w of 0 would be 1, and w of 1 would be 0. So we got a minus sign here. I can switch these around and it'll become a minus, and you got a minus, it'll be a plus then. So you could write this then as 11 integral from, oops, so 11 integral from 0 to 1, 3 times 1 minus w plus 13 w squared over 2 plus 30 w dw. Okay, so let me keep going. Let me write some stuff here. Okay, so we got here. Let's multiply this w in here, so it'll be 11, 0 to 1. So it'll be 3 w minus 3 w squared plus 13 w squared over 2 plus 30 w dw. Okay, so we can combine these two before integrating. So it'll be then 0 to 1. I can combine these also. So this you could write as, so it'll be negative 6. So that's right. So it'll be negative 3 times 2 w squared plus 13 w squared over 2. Then adding those two plus 33 w. Okay, so simplifying this a bit. It's 11 in front, 0 to 1. That's going to be 7 w squared over 2 plus 33 w dw. So then 11 in front, so integrating this, it'll be 7 w cubed over, divided by 3, but there's a 2 down here also, so it'll be divided by 6 plus 33 w squared over 2, evaluated at 0 and 1. So it'll be 11 times, putting 1 in there, it would be 7 over 6 plus 33 over 2. So getting a common denominator, which would be 6 here, so it would be 11 times 7 plus 33 times 3 over 6, which is 99, plus it'd be 106, so it'd be then 11 times 106 over 6, and that's going to reduce to, let you check if you multiply this out and reduce it a bit, it's 583 over 3. So that's our answer. So I'll let you check, I'm not going to do it, but if you try to do the double integral over the original triangle, it's going to be quite messy, but you should get the same answer. So you want to try it, you can. It's going to be kind of, probably have to break into a couple of integrals, you'll see, because it's a messy, the triangle's not nice. So you can see changing variables made it much nicer. So that's our answer, 583 over 3, so we're done.